Both of them are chemically SiO2, but one is crystalline and other is amorphous. If you see a crystalline, the set of arrangement that you are able to see, it is of a repetitive type, and this repeats throughout. If it repeats throughout, we say it has long range of repeating set. While amorphous solid, you are able to see there is a random arrangement. Some places this, some places some other random arrangement. They may have certain part of the arrangement repeating, but that repeats for only small places. That means a short range. Amorphous solids are different than crystalline solids. Crystalline solids have systematic arrangement of particles. Amorphous solids have non-systematic arrangement of particles. So we come to definition of amorphous solids, also popularly called as no-form solids. Substances that appear like solid. For an observer, they appear like solid, but they don't have well developed, perfectly ordered system like crystalline solids. So they are known as amorphous solids, no form solids, also known as pseudo solids. Hindi में झूठे solids. So substances that appear like a solid for an observer but don't have perfectly ordered arrangement. Example from a day-to-day life are glass. You are able to see a glass piece. Plastic, charcoal, koila Hindi mein, soot, lamp black, tar which is used for making roads, okay, butter, soot, again soot, shown how it is made from a candle by collecting that black particles. They are all amorphous solids. Glass, plastic, rubber, butter, charcoal, coke, soot, even one of the allotropic form of sulfur called as plastic sulfur. They are all amorphous. To visualize amorphous, you can imagine particles of the liquid. Imagine particles of the liquid which are always in constant motion. Imagine suddenly somebody photographs that liquid, suddenly. So that photograph that you will get of all liquid particles can be well described as amorphous solid. Again, those who have not visualized before, visualize. Visualize liquid. You know liquids have particles always in constant motion. Visualize them. Then somebody suddenly takes a photograph of that liquid, then whatever you will be able to see, it's amorphous solids. Therefore, they are also called as supercooled liquids. So amorphous solids are also called as no form solids. They are also called as jhoote solids, pseudo solids. They are also called as supercooled liquids. Why the word supercooled? Because we imagine them as liquid only, but particles are very close. We know the particles come close when you liquefy or when you cool it down. So as if liquid has been suddenly cooled, then whatever you feel or visualize will appear is nothing but amorphous solid. Again, amorphous solids are those which appear to be solid, but now you know they are supercooled liquids and they don't have perfect ordered arrangement. Example around us: glass, plastic, charcoal, soot, tar, butter, soot, red again, which is nothing but lamp black obtained from a lamp. Popularly, amorphous solids are remembered as supercooled liquids because as if liquid has been photographed. Characteristics of amorphous solids. Amorphous solids have particles in random arrangements. Some places they can have systematic arrangement, but that will be short-lived or short range, while crystalline solids have long range. observation which has been done, they do not have sharp melting point. Example, glass that we use commonly melts from 1400 to 1600. You are able to see there is no specific melting point. Next, crystalline substances, on the other hand, like benzoic acid, melts exactly at 122.3 degrees Celsius. That's only one and only one temperature value. Such a type of temperature melting point is called as sharp melting point, while amorphous solid have no sharp melting point. That means they melt over a temperature interval. Another property of an amorphous solid is amorphous solids are liquids. When you say they are liquids, supercooled liquids to be correct, that means they will have property like liquid, and we know liquids are dash in nature, isotropic in the nature. Isotropic means they will have same set of physical properties measured in all different directions. Same set of physical properties measured in different directions. We come to the end of this lecture number 2, short lecture, and we like to end this lecture with a very good quote. We are what we repeatedly do. So if you study well and you repeat well, you'll understand well. Excellence is not an act, but it is a habit. You have to develop a disciplined habit. If you develop a disciplined habit is a discipline, then excellence will be a normal phenomenon for you. One of the excellent quote given by a mathematical scholar called as Aristotle.